Something changed in California in the last 48 hours. Not slowly, not theoretically, not somewhere deep in a geological model being processed by a university supercomputer. Right here, right now, on the ground, on the fault, in a pattern that anyone who understands the architecture of California's seismic system would immediately recognize as significant. On Sunday, July 12, 2026, at 3:38 in the morning, the ground moved near Fraser Park, a magnitude 4. One earthquake in the region where the San Andreas and Garlock Faults approach their most dangerous intersection point. That alone was noteworthy. But then, the very next morning, Monday, July 13th, 2026, at 9:40 a.m., a second earthquake struck. This one was a magnitude 4. 3, located approximately 70 miles east along the same fault corridor near the town of Johannesburg in Kern County, 18 kilometers west-southwest of Johannesburg to be precise, at a depth of just 7 kilometers. A swarm of up to 35 additional events has since been recorded clustered around that second epicenter. 2 earthquakes in 2 days in the same fault system, at different points along the same geological corridor, with a swarm building around the second one. And all of this happening at the exact moment that the most comprehensive stress analysis ever conducted on California's fault systems, published just 6 weeks ago in June 2026, confirmed that earthquake stress on the San Andreas and San Jacinto faults has reached its highest levels in at least 1,000 years. Welcome to John's Global Guide. Today we go deep into what is actually happening beneath California right now. Let's start with what the science is actually saying, not what the social media panic is amplifying, and not what the headline oversimplifications are missing. Because to understand why the last 48 hours matter, you need to understand the geological architecture that makes this region the most closely watched and most critically loaded fault junction in the entire continental United States. The Garlock Fault runs approximately 185 miles east to west through Southern California, cutting across the top of the Mojave Desert from the San Andreas Fault in the west all the way to Death Valley in the east. It is a left lateral strike-slip fault, meaning the two sides slide horizontally past each other in the direction opposite to the San Andreas. The Garlock Fault runs east-west through Southern California and intersects with the San Andreas Fault, a roughly 800-mile fracture that extends from the southern part of the state northward into the Pacific Ocean. Where these two enormous grinding systems meet, you get something geologically unusual and mechanically consequential. The opposing directions of motion, the San Andreas moving right laterally, the Garlock pushing left laterally, create a zone of concentrated compression and tension at the intersection point. The Garlock Fault is essentially a giant geological lever pressing into the side of the San Andreas. And at that junction, the San Andreas visibly bows and bends under the pressure. That bend is not a minor geological curiosity. It is a zone where stress accumulates unevenly, where the fault geometry itself prevents smooth gradual release, and where the potential for significant rupture is disproportionately concentrated. Now here's the detail that makes the Garlock Fault so alarming to anyone who understands earthquake science. The Garlock Fault is heavily locked up. It hasn't had a major rupture. Think magnitude 7, 5 for 500 to 1,000 years. That sentence describes a fault carrying an enormous quantity of accumulated seismic energy, 5 to 10 centuries of strain, with nowhere for it to go except outward in a major rupture event. The paleoseismic record, the physical evidence of ancient earthquakes preserved in soil and rock layers, shows past displacements of 2 to 3 meters along the Garlock Fault. Those displacement magnitudes are consistent with earthquakes in the magnitude 7, 5 range. And no such event has occurred on this fault in the historic period, meaning within any time frame where humans have been instrumentally measuring or historically recording seismic activity in California. The San Andreas Fault tells a similar but even more urgent story. The southern section of the San Andreas has not produced a major rupture since 1857, building stress that seismologists say will eventually release in a magnitude 7. 5 plus event, the scenario known as the big one. That is 169 years without a major release on a fault segment where the historical recurrence interval suggests major events approximately every century. 169 years, and the fault does not forget. Every year of relative silence is another year of relative motion between the Pacific Plate and the North American Plate being stored as elastic strain energy in the locked rock of the fault zone. Now overlay that long-term accumulation picture with what a team from the University of Bern, the University of Hawaii at Manoa, and the USGS published in June 2026, just 6 weeks before this swarm developed. According to a study published in the Journal of Geophysical Research, solid earth, tectonic stresses along Southern California's 2 most dangerous fault systems, the San Andreas and San Jacinto faults, have reached their highest levels in at least 1,000 years. The methodology behind that conclusion is worth understanding, because it is what gives the finding its unusual weight. Researchers reconstructed a millennium of earthquake activity using geological evidence, historical records, radiocarbon dating, and advanced computer simulations. Their model tracked how stress accumulates along faults over centuries and how past earthquakes influence nearby faults. The numbers the model produced are specific and alarming. One stretch of the San Jacinto has pushed past any strain the model recorded in 1,000 years, and the San Andreas beside it sits only a little lower, close enough almost to move as one. That phrase, close enough to move as one, points towards something that changes the calculus of worst-case scenarios entirely. Because the researchers did not just find that individual faults are highly stressed, they found that the stress levels on the two major fault systems are nearly matched. And that matching is exactly the condition that historical evidence suggests allows ruptures to propagate across both systems simultaneously, rather than being contained to one. Northeast of Los Angeles, they nearly meet at Cajun Pass, a rugged notch where a break on one fault might jump to the other. Geologists have a name for a junction like this. They call it an earthquake gate, a spot that decides whether a rupture keeps tearing into the next fault or runs out of room and stops. The earthquake gate concept is fundamental to understanding why the current stress configuration is so consequential. A gate that stays shut keeps a quake bottled up on one fault, bad but survivable. Swing it open, though, and one fault hands its energy straight to the next. Two quakes fused into one. The last giant quake here, the 1857 Fort Tejon earthquake, tore through more than 200 miles of the southern San Andreas before stalling at the pass, sparing the San Jacinto. The gate doesn't behave the same way every time. Whether it opens depends on the state of the faults on either side when the shaking hits, and those conditions change over centuries. And right now, in July 2026, a University of Hawaii researcher, Liliane Burkhardt, noted in June that the system is in a critically loaded state due to prolonged stress accumulation and the passage of more than 160 years since the last significant rupture in parts of the area. Critically loaded state. That is the language of the lead researcher, published 6 weeks ago, before the earthquake swarm that started this weekend. Now let's talk about what specifically happened over the last 48 hours, because the details matter, and they are being misrepresented in parts of the media coverage. A magnitude 4. 1 shook Fraser Park early Sunday. Interesting times near the Garlock Fault, AM4. 1 near the western end of the Garlock on Saturday, and a M4.1 near the central section. That commentary comes from Dr. Lucy Jones, one of the most respected seismologists in Southern California, posted on the morning of July 13th. Her post also noted something important for precision. But neither is actually on the Garlock Fault. The first is a thrust fault, maybe the Plato Fault, and today's is in a swarm south of the Garlock. That clarification deserves to be front and center, not buried. The events of July the 12th and July 13th are not confirmed ruptures on the Garlock Fault itself. They are earthquakes occurring in the broader fault network surrounding and adjacent to the Garlock system. But here is why that distinction does not reduce the significance of what is happening. The Garlock Fault runs east-west through Southern California and intersects with the San Andreas Fault at their intersection near Fraser Park. The opposing movements create a complex zone of compression and tension. A smaller fault activating in that zone does not operate in isolation from the stress field generated by the larger structures. The Plato Fault, the fault that likely produced the Sunday event, exists precisely because it is embedded in a tectonic environment dominated by the San Andreas and Garlock systems. Its activation is a signal about that broader stress field, not a separate, unrelated event. Burns described this sequence as a possible indicator that stress is accumulating and that activity on the Garlock could propagate into the longer San Andreas Fault, potentially triggering widespread devastation across Southern California. The Monday magnitude, 4. 3 event near Johannesburg tells an additional piece of the story. A light earthquake occurred at 9:40:55 a.m. on Monday, July 13th, 2026. The magnitude 4. 3 event occurred 18 km west-southwest of Johannesburg, CA. The hypocentral depth is 7 kilometers depth. That is shallow. And the swarm of up to 35 events surrounding that second epicenter represents a cluster of fault movement concentrated at a different point along the same geological corridor from Sunday's event. 2 days. 2 different points, 1 corridor. A swarm developing around the second point. That is a pattern that seismologists monitor precisely because it can indicate that stress is redistributing itself across the fault network, not releasing completely through the small events, but shifting to adjacent structures. Studies indicate the San Andreas Fault is experiencing its highest stress levels in 1,000 years, with experts estimating a high probability of a major earthquake, exceeding magnitude 6, 7 in coming decades. And what the director of the statewide California Earthquake Center at USC said publicly last week in response to the Burkhardt study removes any remaining ambiguity about the quantitative picture. We have been lucky in California not to experience a large urban earthquake since 1994 on Northridge, Ahmed El-Banna told the Sacramento Bee. In order to release the stresses, the stress levels that we are talking about in this study, we need a magnitude 7 or larger earthquake. A magnitude 7 or larger. Not to cause additional stress, not to partially relieve accumulated strain, to release what is already built up to the highest levels recorded in a millennium. Now let's zoom out and look at the broader seismic context in which this California swarm is developing. Because one of the most important things to understand about fault systems is that they do not operate in isolation. The seismic energy generated by earthquakes does not stay neatly contained at the epicenter. It travels outward through the crust, and in well-documented cases, it transfers stress to neighboring fault segments, a mechanism called Coulomb stress transfer that has been measured and validated in the scientific literature repeatedly. The Ridgecrest earthquake sequence of 2019 is the most recent powerful demonstration of this in California. The magnitude 7.1 main event measurably increased stress on the Garlock Fault by approximately 30% and triggered documentable aseismic creep, physical fault movement without a major earthquake, across a 12 to 16 mile section of the Garlock system. A fault already carrying centuries of accumulated strain absorbed another 30% on top of that. And it responded with movement. That is the behavior of a system approaching a threshold, not resting comfortably below one. Now factor in what happened to California's broader seismic environment in June 2026. A magnitude 5.6 earthquake struck near Redwood Valley in Mendocino County, producing localized damage and power outages across Northern California. And on the same day that earthquake struck Northern California, Venezuela experienced its catastrophic doublet of magnitude 7, 2, and 7.5. The connection between distant major earthquakes and stress redistribution on regional fault networks is a well-established phenomenon in seismology. Large seismic events send surface waves propagating across the globe, and in documented cases, these waves have triggered local seismicity on faults that were already near their breaking points. The Ridgecrest sequence loading stress on the Garlock in 2019 demonstrated this mechanism at a regional scale within California. The Venezuela doublet and the Northern California magnitude 5. 6 represent additional inputs into a system that was already, as of the June 2026 Burkhardt study, at its highest stress levels in a millennium. This is the context in which the July 12th Fraser Park magnitude 4, a 1, and the July 13th Johannesburg magnitude 4. 3 swarm are occurring, not against a background of ordinary California seismicity, against a background of the highest documented fault stress in 1,000 years, an active swarm developing along the Garlock corridor, fresh stress additions from regional events, and a Garlock fault that hasn't produced a major rupture in 5 to 10 centuries, and showed measurable response to stress additions as recently as 2019. Now there's a critically important distinction that good seismic science demands be stated clearly and repeated. The findings don't predict an imminent earthquake. Even after years of technological advancement, earthquake prediction isn't terribly reliable. The study isn't 100% predicting that a cataclysmic earthquake is absolutely going to hit California in X amount of time. That is not hedging or false reassurance. It is an accurate description of the current state of earthquake science. The timing of fault rupture, the specific moment at which accumulated strain overcomes fault friction and releases, is genuinely not predictable at the level of days, weeks, or even years with the tools currently available. What is predictable, what the physics absolutely allows us to say, is that the conditions required for a major earthquake in Southern California are not building toward some distant future threshold. They are, right now, at the highest levels recorded in a millennium. There is one more dimension to this story that requires serious attention, and it is the scenario that almost nobody in the public conversation is discussing with sufficient technical depth. The earthquake gate at Cajon Pass. Matched tension like that appears to be what swings the gate open and lets a rupture jump across. The faults showed it in 1812, when one study found a single earthquake tore through both at once. In 1812, a single rupture propagated through the Cajon Pass junction and broke across both the San Andreas and San Jacinto fault systems simultaneously. That event is not a theoretical construct. It is a documented historical precedent for cross-gate rupture in this exact system, and the current stress configuration, both faults running at historically high levels, nearly matched in their loading, is the configuration that the Burkhardt model identifies as most consistent with gate-open propagation. A quake that broke both faults through the pass would dwarf one trapped on a single fault. The shaking would slam the most densely settled parts of Southern California, including the Los Angeles Basin and the inland valleys to the east. Tens of millions of people would be affected at once. The 1994 Northridge earthquake, a magnitude 6. 7 that remains one of the costliest natural disasters in U.S. history, would be approximately 44 times weaker than a full southern San Andreas rupture. We don't want to scare you, but the big one is coming. We don't know when, but we know it'll be at least 44 times stronger than Northridge and 11 times stronger than the Ridgecrest quakes in 2019. That differential is not a dramatic flourish. It is the mathematical consequence of how earthquake energy scales with magnitude. Each whole number step on the magnitude scale represents approximately 32 times more energy released, a magnitude 7.9 or 8. Zero event releases energy that dwarfs anything California has experienced since 1906. And now look at what is specifically developing along the Garlock corridor as of July 13th, 2026. The Monday morning magnitude 4. 3 near Johannesburg struck at a different point along the fault system from Sunday's event. 2 separate junction points, 2 separate activation events within 30 hours, a swarm of up to 35 earthquakes clustering around the second epicenter. This represents the fault network not just producing one isolated event and going quiet, but continuing to move, continuing to release energy at multiple points along a corridor that connects directly to the most critically stressed major fault system in the western United States. Burns noted that Sunday's tremor struck at a rare meeting point between these two systems, an area that had not experienced a quake of comparable strength in more than 26 years. 26 years of quiet at that specific junction. Now 2 events in 2 days, and a swarm building at a second point 70 miles to the east along the same system. The oblique slip character of some of these events, containing both the horizontal lateral movement of a strike-slip fault and upward thrust motion, is a detail that carries specific meaning. Thrust components in earthquakes at this junction suggest compression in the fault system, not just lateral sliding. Compression accumulates differently than pure strike-slip loading. It tends to build stress faster at specific geometric pinch points. And the junction of the Garlock and San Andreas, where the 2 opposing fault motions physically push against each other, is exactly the kind of geometric structure where compressive stress concentrates. Let's now talk about what this means for Northern California, because the seismic story in 2026 is not exclusively a Southern California story. The June 24th magnitude 5. 6 near Redwood Valley and Willits was itself a historically notable event, a magnitude that had not been recorded in that specific region in the modern instrumental record going back more than a century. That earthquake struck at a location where the Northern California fault network shows its own signs of evolving stress. The Hayward Fault runs beneath the densely populated East Bay cities of Oakland, Berkeley, Hayward, and Fremont, making it widely considered the most dangerous urban fault in the United States. It last produced a magnitude 6, 8 earthquake in 1868, now over 155 years ago, and a USGS assigns a 33% probability of a magnitude 6. 7 plus rupture in the next 30 years. 155 years since the Hayward's last major rupture. A fault running directly beneath bark tunnels, Bay Bridge anchorages, and tens of thousands of unreinforced masonry buildings in Oakland and Berkeley. The Calaveras Fault branching from the Hayward system. The Green Valley Fault. The network of structures crossing the Bay Area represents a different flavor of the same fundamental problem that dominates the Southern California picture. Locked faults carrying centuries of accumulated energy beneath one of the most densely populated regions in the United States. The 1989 Loma Prieta earthquake, a magnitude 6.9 that struck during the World Series, became one of the most televised natural disasters in American history, remains the last major rupture in the Bay Area fault network. That was 37 years ago. The fault system did not exhaust itself in 1989. It released one segment's accumulated strain. Every other segment of the Bay Area fault network has continued loading in the years since. What all of this adds up to, on July 14th, 2026, is a seismic landscape that the data describes with unusual clarity. Southern California fault stress at a millennium high, confirmed by the most sophisticated model ever applied to the system. A Garlock Fault, carrying 5 to 10 centuries of unreleased strain that already responded with measurable movement to the 2019 Ridgecrest Stress Edition. A Cajun Pass earthquake gate, currently sitting in the stress configuration most associated with cross-fault propagation. A 2-day swarm developing along the Garlock corridor with events at 2 geographically separated junction points. A Northern California fault network showing its own signs of evolved stress. And a broader regional seismic environment that received additional stress inputs from both the Venezuela doublet and the Northern California magnitude 5.6 within the last 3 weeks. We should certainly expect to experience large earthquakes in our lifetimes, one of the researchers told LAist last week. That sentence is about as close to a categorical statement as earthquake science gets. Not possibly. Not under certain conditions. Expect them. In our lifetimes, the science is not hedging anymore. The models are telling a story that the data from the last 48 hours is now annotating in real time. What does all of this mean practically for everyone watching this right now? The same things it always means, the same things that most people have not yet actually done, despite years of being told the same message. Have an emergency kit ready, water for at least 72 hours, non-perishable food, a hand crank radio, backup battery power, copies of important documents. Know how to shut off the gas supply to your home. Know where the structurally safe spots inside your living and working spaces are. Have a communication plan with your household before shaking begins, not while you're running for the doorframe. Sign up for Shake Alert early warning notifications. The system that delivered warnings before both Sunday and Monday's events is the same system that will give you every available second of advance warning when the magnitude is considerably higher. If you live in a building constructed before 1980 and it has not been seismically retrofitted, find out its status. The difference between a retrofitted and an unretrofitted structure during major shaking is not cosmetic. It is structural survival versus structural collapse. And if you are in a region underlain by soft sediment, any valley floor, any filled bay margin, any loose alluvial deposit, understand that your local ground motion during a major event will be amplified significantly compared to adjacent hard rock sites. That amplification is documented, predictable, and something your local geological survey can tell you specifically about your address. The swarm in the Garlock corridor that developed this weekend is not a confirmed prediction of imminent catastrophe. Nobody with scientific credibility is claiming that. What it is, sitting in the context of the June 2026 Burkhardt study, the 2019 Ridgecrest Stress Edition, 169 years of southern San Andreas loading, and a fault system at its highest stress levels in a millennium, is a signal that the background conditions are exactly what they need to be for a major event to eventually occur. Not eventually, in the geological sense of thousands of years from now, eventually in the sense that just every piece of physics-based evidence currently available points toward a timeline that overlaps with human lifespans that are alive and active in California right now. The Garlock Fault has not spoken loudly in 500 to 1,000 years. This weekend, it started making noise. 2 earthquakes, 2 junction points, a swarm of 35 events, against the backdrop of a study that described the surrounding fault system as critically loaded, published 6 weeks before the noise began. Whether the next signal is another small earthquake, a moderate magnitude 6 foreshock, or the beginning of the sequence that finally delivers the energy release the system has been promising for 169 years, nobody can tell you with precision. But the direction of the evidence, accumulated over centuries and now confirmed at the highest scientific resolution ever applied to this problem, is not ambiguous. California's most dangerous fault junction just moved, and the scientists watching it most closely are not relaxing. Neither should you.